yesterday. Give me a second. All right, thank you. So welcome to the session. Good evening, and thank you so much for joining. My name is Levix Dudi here, representing DataBreed Africa. We're also having Helen Mati on the call from DataBreed Africa as well. And I know this is the third day. We've had this training the other day. Yesterday we had given you guys an assignment to do, so that's why we were not able to. We preferred to give you time yesterday to work out on that. But I'm hoping also that we've been able to at least do something in between the time, from the time we were here and now. So today we're going to do largely SQL, that is structured query language. This is another very important, database language that is used across fields. You'll find a data scientist using SQL. You'll find a data analyst as well using SQL. You'll find a data engineer. You'll find even cybersecurity professionals using SQL. So SQL is one of those tools or languages that somehow cut across many, many fields. It allows you to interact with databases, left, right, and center. You're able to query them. You're able to modify them. You're able to retrieve data out of there. You're able to even, use it across various facets of technology. So we're happy to have you here. I think we'll not take much time. Maybe we can just let in Mati to proceed. But maybe before that, before we let in Mati, maybe somebody just unmute and say hi, just one or two people. And I hope the session is going to be interactive, probably more than it was the other day. We don't like trainings where people just join in and then they stay quiet behind the camera. So we'll appreciate if you can be able to participate. And we're also hoping that you have your computer with you so that you can practice on the go. Yes, how many of us, maybe by a show of hands, how many of us have their machines, perhaps? Let me know how many of us have their machines. Yeah, thank you, Eric. Thank you, JM, Joseph Mwangi. Thank you, Eric Mwangi. There's Eric Mwaura. There's Brian. Okay. How many of us have their machines with them? Let me just know everyone who is on the call already. Jones Kihuna, that's good. Let me know if you have your machine with you, because these are technical trainings. They require you to have at least a machine. That's good. Sifa, Pasimei. So those are about 6 people. The rest of us, do you have your machines? Let me just see by a show of hands. Damaris Mutiso, that's good. Brian Kimutai, that's okay. Gendra Imbukure, that's okay. Thank you. Lame Kirungu, that's okay. So I can see quite a number of us have their machines. But that is just a fraction of us. Let me know the rest of us if you still have your machine as well. I think that would be the best scenario so that you're able to practice on the go. Yeah, so I think that's it. Let's let in Helen. Also, we'll be having group work after this, which Helen will be able to share with us the exercise, I think later in the day or tomorrow, so that we're able to work in groups. We gave you the assignments to do as individuals. So we'd also like to enable you guys to work in groups. For those who are willing, that is, this was a free program, and it was even the group work will be optional. If you want to be part of it, you'll be able to tell us whether you want to be part of it or otherwise. All right, thank you so much, Helen. Maybe you can go in now.
Thank you. Can you hear me?
Yes.
Okay, thank you. So thank you for having me once more. And thank you to everyone who has made time to join our session today. I hope the other one was helpful and impactful to you, and you've learned something, and that it has given you a clearer way on what you want to do in your data career. So today we are going to look at, the other day we looked at Python. So today we're going to look at SQL. And the reason we are looking at, we're going to go through SQL is because just like Python, anywhere in your data career, you're going to be required to use Python. At some point, you'll be required to retrieve data from a database or to add data to a database. If you're an analyst, you'll be required to fetch data from a database, maybe to do some visualizations and such. So SQL is very important across all the stacks, all the data careers, or rather all the stacks in data that you're going to come across. So that's why we're going to do SQL today. So SQL, first of all, SQL stands for, before we go to the definition, I want to show you something small. Just a minute. So yeah, I'll share right after this. So SQL stands for Structured Query Language, and it's a standard programming language that is used to communicate with relational databases. And it allows you to create a database, to retrieve, to update, or to delete data. So generally to manage data within a database. So if you're wondering what a database is just a more organized way of storing data. Most of you, I know you're more conversant with things to do with Excel sheets, CSV files, the most common ones. But in organizations, as data grows, there's need to expand, and you can't just keep on expanding in using or creating more CSV files to store your data. So there was need to come up with a better way that could store data, and hence that's why they came up with the databases, so that you can store a bit larger amount of data. You can do a lot of things within it. And as your organization grows, you are able to handle your data as it comes. I think most of the definitions here are things that you know, but just for the sake of it, let's go through what is data. So data is just raw facts and figures with no context attached. For example, when you get a piece of paper that is written, let's say number 1 with your name and just a figure there, that's just data, because at a glance, you're not able to know what is this statement supposed to mean. But when someone adds or adds some more flesh to it, or arranges this statement into a better way, it becomes information. So someone else might come and just say, so number 1 is the name of a student, and the number given there is a score that they got from a test. So data is generally just raw facts and figures that have no context. They can be wordings or numbers or measurements, but without someone coming up with adding more flesh to it, you're not able to deduce what this data is supposed to tell you. And that's how you come up with information. So data that has been arranged in a way that is more in a more meaningful way is what we call information. As I mentioned, for example, number 42 is just a number. If I tell you number 42, it could mean anything. It could mean a size, it could mean a measurement, it could mean a part of a number. But if someone comes and says age is 42. That adds a little bit of context to it to mean that I was referring to 42, the years or the number of years. So SQL will be largely used by analysts, engineers, data scientists, business intelligence professionals, just as I mentioned earlier. So it is very important for you to be proficient, or rather to be conversant with SQL. So there are two types of data, two common types of data. So data can be structured, unstructured, or semi-structured. So structured data is data that is neatly arranged, that, for example, in an Excel sheet, that is structured data, that you can see columns and rows, and you're able to see this is a sales data, these are scores from a class and such. Unstructured data, on the other hand, is data that does not have a format. For example, an email. An email, okay, as much as you see it on your machine and it has the heading, the subject, it has your email there, it has the recipient, it has the body, it has, when you extract that email and you paste it, let's say somewhere on, let's say on a Word document, the structure is not as organized or as more direct as the one of a structured data. So unstructured data does not have a fixed format, and its example is emails, videos, photos, social media posts, PDF files. So when you extract this data in these formats, it is not as direct as the data that is in a spreadsheet or in a CSV file. It is in a way that it looks a bit more complicated. And then we have semi-structured data that has some organization, but is not as rigid as the structured data. For example, log files. When you look at a log file or a JSON file, you can read through it and you are able to say what kind of a data is this. For example, when you get an error and you pick and it prints the log of the error, you're able to see that this is an error, but the way it's structured is not as direct as the structured data. So it is, in a way, looks structured, but it is not as structured as the data that is that is tabulated. Because, for example, in a JSON file, you might find it is separated by commas, semicolons, a dash or slashes and such. So it is readable. It looks like it's a bit organized, but it's not as organized as the data that is tabulated. So for example, this is structured data. You have the ID, you have the name, you have the price. It's just as you see it in an Excel sheet. So you from just from at a glance, you're able to see that this is data for, let's say, a cafe or a sales data, because it has give you the ID, it is giving you the name, the price, and you can easily read through it. Unstructured data is like this, for example, hey, just checking in about the meeting tomorrow. So it has no fixed columns that it can tell you directly what, how to manage this data, because it is just a statement. It is separated by, it has many characters within. It's look like a block of information. So it's not stored in a more structured way, like this sales data on the other side. So SQL was specifically built to manage structured data, and that is data that lives in tables. So structured data, as you've seen here, it's data that is tabulated, it's in tables. So it has you expect it to have rows, to have columns, and to have rows, columns. Yeah, to have rows and columns. Yeah. So we go this part. It's more of a check-in. You're going to do once I send this document to you. You can go through it slowly and just check if you've understood that part. So the next module is we're going to look at databases, how they are created, and then at the end on the next module is when we'll look at how SQL and databases they're related. But all through this, it's the general flow of you to understand how information comes to a need, to the need of being in a database, and how we get in, or how we put data into that database, and how we manipulate data within that database. So we're going to do this step by step. So what is a database? So we're going to take, for example, imagine a coffee shop or a sales shop, or let's do an example, or a retail. Let's say a company that is making chairs. So every single day, in each department, something is moving. We have, let's say on the sales team, we have people who are doing the sales for the chairs. At the end of the day, they'll be required to submit information on who sold how many chairs, where were they sold, what identity of that batch was sold, how much was sold. There's going to be another one in production. So the production department will need to account for how much material did we use, how much did we produce, how much losses did we make, how many chairs that did not make it to the quality that we need. So we had a bit of losses there. They need to account for everything that was happening in production. And then we're going to have the finance team. Finance team is also going to account for this money was allocated to which department, how was it used, which item is costing us more, are we making profits, are we making losses, and whatnot. They're going to account for every coin in there within that organization. And then there's going to be a marketing team. They are going also to account for the marketing strategies they have used, the customers that have come, the customers that they are losing, their products moving, how is marketing going out there, how much has it cost us, how much our strategies are effective, are they bringing us any profits. So each department will be generating its own data, and all this data under one, remember it's just one company. All this data, the management team, the management committee at the end of the day, or rather the stakeholders, they want to see everything at once. How is every department performing? So this data needs to be stored in one big in one big database where at any given point I'm able to pick any information from any department at any given time. I don't have to reach out to Department X to get what that I want. I need to have all this in one. And since all this in one cannot be stored in a simple tool like a spreadsheet, we store it in a database. And there are very many different types of databases. But in this case today, we're only going to do one of them. So in simple definition, a database is an organized collection of structured data stored electronically, designed to be accessed, managed, and updated. All that we have seen. So the reason why databases exist is one, which we have mentioned, speed, finding one record among 50 million instantly. So imagine in this company for making chairs, someone comes out of somewhere, or a stakeholder just comes out of nowhere and says they want to see how many chairs salesperson X sold in the year 2019. 2019 is years back, but it is very, or for audit purposes, let's say for audit purposes. So this auditing team has come and they want to see how much you made in the year 2019. So what will happen, to access this data easily, instead of just going to dig into files to find or manually find who did what which year, we need a database where just in a few steps or in a few queries, we are able to find the records that are needed. So one of the problems that a database was solving was speed in accessing data. 2 is consistency. So the same customer's number shouldn't be different in 5 different files. So for consistency purposes, if you have if this company has client X who keeps on coming back to buy chairs for their retail shop, instead of recording this customer's number every now and then, we have one number that every time they come, we can use it. So in this way, we don't have to have a lot of bulky information just referring to one person. So instead of that, we just have one number for one client. So that is for consistency purposes. We don't have to keep on recording one number every time and it is the same number. Concurrency access. So 100 of employees updating data at the same time without corrupting it. Now imagine every department now is updating a given Excel sheet. Let's say they have put it on Google Drive, or for example, this drive that we are sharing here. Everyone is updating something at a certain time. So imagine if all 20 of us in this call, we start updating one sheet, it's going to hang. It's definitely going to hang. It's going not to work for some of us. You'll have to wait for some to finish. It's going to lag behind, or it's going to take a lot of time to load. So for purposes of updating a lot of data at once, there was need to have a database. The other reason is reliability. Data survives crashes, power failures, and whatnot. Reliability is for, regardless of whether what has happened within the organization, we're still going to our data. Imagine storing in all those Excel sheets and then the person who's storing, or the computer that serves as a server, has crashed or you lose it. We're not going to have that data. Basically, we've lost that data. So to avoid such things, there was need to have a database. I had mentioned Excel sheets and database. So the four main differences is that Excel sheets, between Excel sheets or spreadsheets and databases, is that for Excel sheets, it's for small data and quick personal analysis, even for yourself. An Excel sheet is where you store your small calculations. If you want to do your planning, your weekly planning, your budgeting, Excel sheets is best to handle small amounts of data like that. Database, on the other hand, it will deal with very large amounts of data, and it is shared across many users. So you'll find one database that is shared within the whole organization. Enforcing rules. So in enforcing rules, Excel sheets they are a bit risky and causes conflicts. We have seen that already when I was saying you can't access many people at once. It's going to give you errors, or it's going to hang, or it's going to crash. On the other hand, a database was designed for that. Many users can use the same database at the same time without the risk of losing any data or having the system crash. Another difference is enforcing rules. In Excel, if you use Excel, this is done manually. And let's say I've set a rule and someone else comes to the same Excel sheet and they do something different without knowing what rule I had set, it's very easy to start getting errors. So therefore, it means your system is going to break easily. In case someone who doesn't understand how this was set or how it's supposed to be used, it's going to bring problems. On the other hand, a database, when you're creating a database, which we are going to see in the coming modules, you have to build in constraints. So in these constraints, or enforcement of rules, since they are inbuilt, it's very hard to get these errors or to have system crash outs or to have anything happening to the database. Searching of data. In Excel sheet, if you have ever opened an Excel sheet that has very many rows, most of the times it will take even time to open or to load. And when you do, let's say you do some type of formatting, if you have a very large database, sometimes it will take time and you'll have to close it and open it again, or it will tell you that the system is crashing, or there's usually some error that you're going to get if you have so much data that is stored there. While on the other hand, a database, since it can store as much data as possible, you won't have that problem. Use of indexes. We're going to see the use of indexes, but ideally this is to mean if it's data that is related, let's say, to sales, you can index it to say, I'll use a figure, let's say number 1. So every time you type in number 1 or you want to query number 1, you know what kind of data you want to get at that point. So it is very easy to search because data is optimized and is organized in a more simpler way or in a more better way for holding a lot of data. Or connecting related data, that is customers orders. So for Excel sheets, when you have, if you have seen how a spreadsheet looks, or it has sheets down there, so you can store a lot of different data that is related to each other in each sheet. But when it comes to lookup, you have to do it manually. For example, if I want to check orders from a customer, but on the spreadsheet we have 2 sheets where one sheet is for customers, the other one is for the orders. So to create a link, between these two, we have to do it manually using VLOOKUPs, we have HLOOKUPs and such. So you have to do it manually. And this might be a bit hectic. I think when I was learning Excel, these are some of the things that used to scare me. But on the other hand, in database, when you're creating a database for your tables or for your tables, you are always going to do relationships, and then there's an easier way of querying. You can do SQL queries that are going to join them together and just give you the results that you want. So I hope you're together, you've understood why we need to use a database instead of an Excel sheet when it comes to managing very large amounts of data. So database management system. So a database management system lets you create, read, update, delete, and manage data in a database instead of just manipulating the row itself. That means instead of every time when you want to manipulate some data, you have to open the whole file and start going through to a specific row because you want to update it. Imagine you have 5,000 rows of data and you need to search to a certain name and you're not even sure where it is. So imagine going through it manually. It's going to take you a lot of time. So a database management system will help you to create, read, update, delete, whatever you want to do in a much easier way without doing this in a more manual way. Relational database management system. So a relational database management system is the one that stores data in tables and rows. This is basically structured data. So relational database management system is for relational data because it is stored in tables and in rows, unless those tables to be related to one another through keys. So once you've stored this data, for example, you have data for your customers and the orders, you can do a link between the tables so that they can be related. It can show a relationship between each other. It can show that this is the table for clients, these are the orders, and this is how we connect the two of them. So when you want to query your database to know which client was buying what, which client was spending most, there's a there's a relationship between the two, and it's easier to query the database when they're related. So there are very many types of databases in the industry. For us today, we are using this one, SQLite. There's PostgreSQL, there's MySQL, Microsoft SQL Server, Oracle Database, MongoDB. So for the first ones, these are for like what we're doing today, but they are a bit more complicated. For us today, we're just going to use this one in Colab because it doesn't need a lot of setups, a lot of installations. It's more direct. But when you start using these ones and you're already conversant with how to create queries, how to create databases, the language is the same in all of them. What you will do today is what you'll do when you start using MySQL, when you start using PostgreSQL. So this one is just for general, but after this, I can give you a setup for Postgres, which I mostly use sometimes, and then you can go practice on your own. So where SQL fits, assume you are the analyst and you work for company X, and your manager wants to know the performance of the team for the month. So what they'll do, they'll give you the request. So it's up to you to come up with a query. And then the query goes to the database management system, let's say SQLite, Postgres, or whatever database management system you're using. And then the database that is within the database management system is where the data is stored. So you write the query, it goes through a database management system, and then it goes to the database and it gives you back your result. So we had already gone through the definition of what is SQL, and I think by now you have a rough idea of what SQL is and why it's needed for databases. So for these ones, you're going to go through and do a knowledge check on yourself, check if you have understood what a database is, what a DBMS is, relational databases and whatnot, and SQL. Generally what we've done on the theory part. So model 3, the database concept. So since you're dealing with relational databases, we mentioned that it's for structured data, and we said structured data is stored in columns and rows. So within a database, there are tables, and each table is the one that holds certain kind of information. For example, we can have a database for a school database. In a school database, we'll have a table for students. Let's name our database school. The general name for the whole database will be school database. But within the school database, there are a lot of things that happen in school. We'll have a table for students. We can have another that stores information about students. The student ID, I believe all of us, we had a student number when we were in school. So it will hold your student number, your name, your class. And then we can have another table here where it has the teachers table. It will give us the teachers' information, their number, their names, what they teach maybe. We can have another table maybe for subjects, what subjects are being taken in that school. You can have as many tables within a database. So that's just it. I think I've been clear on what a table is, what rows are, but there's something else called a schema. So a schema is like a blueprint of the table. It has columns, data types, and rules. For example, before you fill any data in that table, let's say this student's table, you can set some rules for it. I don't know if I should use the word rules. You can set some rules or some way of doing it. For example, you can say, for the first row, I need it to hold the student's number. And this student number has to be an integer. So at any given point, when you input in data in this table, row number 1 will always take an integer, which is the student's number. Then you set another constraint, you say number 2 should be the name. Row 2 should be the name. And the name for these students, it has to be characters. There is no way a name will have a number in it. So you have to set it right there that any information or any value that goes to any of these in this column, it has to be a character, not an integer. So that is what we mean by schema. And then we have things we call keys. So a key in a database, we have primary keys and we have foreign keys. So a primary key in a column, it's an identifier that shows the uniqueness of that specific table. So a primary key is a unique identifier of a row in a table. No two rows can share the same primary key. For instance, we are talking about a student's table in a database. Every student, even from your high school where you were schooling, everyone had their unique number. So every row will hold a unique number from a number that is different from the other. So we can say, since that in that specific table, the values in the ID column, they are all unique, they're different. There's no way you'll find two of them that are the same. So it means every number in that row, however, regardless of how many they are all going to be different from each other. So that will be the primary key of the column. That will be the unique identifier of that table. So for in the students table, we'll have the student ID as the primary key, since is the unique identifier in that specific table. So that is called a primary key. And in every table, however many they are in a database, you'll find that every table will be having its own unique identifier. A good example that is given here is your national ID. So everybody in Kenya, everyone has their own national ID number. So there's no way we'll be sharing our ID numbers. Whether you're going to replace it, whether you lost it and got another ID, everyone is going to have a unique number. And then we have foreign keys. So a foreign key in a column in one table that refers to the primary key of another table, creating a relationship between the two tables. Now, a good example is this. We have a customers table here, and we have orders table. All this, the two of these, they are all in one database. So we have, in our database, we have customers table and we have orders table. So in customers table, we have customer ID and name. So we only have two columns. So in our customers table, we are going to have the ID of our customers and their names. And then we're going to have orders table. In our orders table, it is going to contain an order ID, a customer ID, and the item that was bought. So in our customer's ID, since we said a primary key is a unique identifier in each table, and we can see in this, it's the customer ID. So for instance, this 1, 2, 3, 4 is going to be like that and no repeating of any number. So that will be our primary key. And then when it comes to orders, orders has order ID, customer ID, and item ID. But remember, this is the orders table. This is the orders table. So the unique identifier in this table is the order ID. Every order is going to have a different number. So in this case, the order ID is going to be the primary key in this orders table. But again, we also have the customer ID that we have included here. And the reason we included it here is because we want to have a relationship between the two. So since the customer ID here is a primary key in this is a primary key in this table. In this other table, it's going to be called a foreign key. So the relationship comes in that the primary ID, the primary key in this has come to this table. Now it's a foreign key here, and therefore we can have a relationship between two. Because when I pick number 1 here, and I have linked it to here, I'm able to get the customer name, I'm able to get the order ID, and I'm able to get the item name. So that's how a relationship has been created between two orders. So ideally, primary keys and foreign keys, they are used to create relationships between different tables in one database so that we can have a relationship. Remember when I mentioned using CSV files, Excel files, creating a relationship between two sheets to get a link between them, there's a lot of manual work and manual calculations to do to retrieve that information. But you see, in a database, you just have to arrange your tables in a well-organized manner. You identify the unique keys in each table, and you see how you can add it to another table to become a foreign key there, and then how a relationship can come up between the two tables or 3. So the relationship can be in as many tables, as many as that they can exist. So this is what actually the link exactly, you see the link we've said, the customer ID in orders is a foreign key pointing to customer's ID. As I'd mentioned, that's how a relationship is created. This link is exactly what SQL later answers the question, show me every order along every customer's name. That is the example that I had given. If you want to see the orders and the customers, which customer bought what, you're able to pick their ID. It is the same ID that is going to reference in this table. So you're able to pick their names, the order number, and the item that they bought. And this is what we call a join in SQL. We have a whole module for doing joins, but what I mean is this is how you join two tables, how you can query more than one table by using foreign keys. I'll leave you with to do this once and to read through the common mistakes and do the coding exercise later on once I have given you this this notebook to work on it. So we move to module 4, which is SQL fundamentals. The SQL fundamentals. So SQL is not just one type of a command. It's a toolkit with 5 departments, each responsible for different job. Understanding these categories upfront will make every feature lesson click in place, because it will make you understand what to use where and when. So SQL has 5 sub-languages or tiny categories within it. So we have the first category, it's the data definition language. You'll see lots of this when you're doing SQL. And this one defines or changes the structure of the schema. You can create, alter, or drop the table. So this is for creating, altering, or dropping the table. It's called the data definition language. As you can see here, it states that you can change the structure of the table with it. The other one is data manipulation language. It changes the data inside the table. So it basically can update the data. It can update, it can delete, it can insert. So it plays around the data that is already inside. Please note that this says it changes the data inside the tables, but this one says it changes the schema. As I had mentioned earlier, if you remember, what a schema is how you've defined how you want the table to be built. It's like a blueprint. You want the first row to be just integers, and the integers should be the student ID, and row number 2 should be, sorry, the other column should be the names, and should be in form of characters. So it can change the blueprint. So that is the data definition language. Manipulation, you can change data inside the table. And then we have the data query language. So this one reads, asks questions about the data. So in this, you'll be doing a lot of select, especially when you want to retrieve data from the database. The first command that you will learn will be select, because it is the one that retrieves data from the database. And when you start doing SQL, you will do a lot of selects. The other one is data control language. This one controls permissions, who can do what. So it can grant and revoke permissions. For example, when I was given the example for a company that makes chairs, as we all know, the most sensitive department has to be finance. No company wants everyone to be knowing how their cash flow is going, how much they're making and whatnot. So imagine if we had a database and everyone within the organization is able to access. Remember, all the data from that organization is in one database. All of it is there. But imagine if we didn't have any control over permission of who has access to what. It means even someone in sales or in marketing, they're able to access data from finance and just see how money is flowing within the organization. Like ideally, there's no control within the organization. Everyone at any point has access to every kind of data in that organization, and that is not a very good thing. So we have data control language that controls who can access what. So as much as this database can be accessed by everyone, there has to be a set of rules of who can access what and when. And then we have transaction cost language. This manages grouped changes as one safe unit. So we'll look at commit, rollback at the end of this. So in an analogy form, the data definition language is the architect who designs the building, as I said, the blueprint. Data manipulation is the movers who bring the furniture in and out, the data within the table now. Data query language, the visitor who walks through asking, where's the kitchen? Where can I get water? Where's the food? Where do I get the information generally? Data control is the building security, decides who comes in, who goes out. Transaction control language is the save changes and undo buttons of every action. So in case you realize, or in case there are changes in the database that has been done, TCL will do it. Or in case you want to control Z, this is the work of transactional control language. So we're going to look at the basic syntax of SQL. So rule number 1, SQL is written in uppercase. It has no lowercase. So all the commands in SQL, they are in uppercase. That's why you've seen here, they are all in here. The example commands, they are all in uppercase. Not required, but it's a strong convention that makes code readable. For example, if you don't write, if you decide to use lowercase and you have very many lines of code, you'll not be able to easily see where the command applies or where you wrote the command. So for it to be more readable, because not all your SQL queries are going to be as short as this. Sometimes you'll be required to do queries that are joining so many tables, doing so many queries, and it's going to be a bit a lengthy, let's say a lengthy line block of code. So imagine it's all written in just small letters. It's going to give you issues when you want to know, where did I put a select, where did I revoke, where did I do the undoing, where did I save? So for readability purposes, use uppercase, avoid using small letters. After every statement, you end with a semicolon. If you don't end with a semicolon, your code will not run. Text values go in single quotes. Numbers do not need quotes. So every time you have a text that you want to add in your query and it's in a text format, use single quotes. SQL is mostly not case sensitive for words, but strings data is case sensitive. For example, if in the database the word coffee was written with a capital C and you come query it with a small c, you will not get the results. So you have to be keen on that as well. White spaces and line breaks do not matter in SQL. You can leave as much space between this line and the code will still run. So what to take note is the most important part is this. Just know that queries need to end with semicolons. You take note of the single quotes for every text that you use and the case sensitivity in string data. So this is a basic syntax of an SQL block of code. So as you can see here, they have done select. This is the command. Assuming our database has assuming that our database here has this column and this column. So we select name, age, students, where age is greater than 14. So in our database, or rather in our table called students, we are going to pick all the names and the age of students who are over 14 years of age. So it will display to you all that in one list. So for this part, I'll leave you to do it, to practice on your own, to see if you have understood what DDL is, DML is, DQL, and the rest. There's a small coding exercise here. Make sure you also try it out. I promise you it's going to be very interesting. Once you know how to create databases and to query them, you're going to enjoy doing this. The next module is Google Colab setup. As I had mentioned earlier, the reason we are using Colabs is because it does not need a lot of installations and setups. And so that's why we use a library called SQLite 3. So this one is an inbuilt library, and every time we import it, we'll be ready to just use databases within the Colab. So that's why we use this. The other ones, you'll need a bit of a guide on doing the setups and whatnot. So, and these are the simple steps when you're using Colabs. So we import the library, this one, it brings the toolkit that is used to work around the databases. You connect to a database file. So we're going to either create our own or connect to an existing one. In our case, we don't have an existing one, so we're going to build ours from scratch. You create a cursor. A cursor works like a pen for your writing and reading SQL. And then we are going to execute SQL. This is where you'll have to, someone has their hand up. Yes? Someone's hand was up. Okay. And then we have execute SQL. This is where you have your block of code. And then you run a command. And then you commit changes. This is where you save permanently. If you don't run the commit changes, you're not going to save the work you've done. So anytime you're executing it elsewhere, this will be treated, this query here will be treated as a new query every time because you've not saved the changes. And then at the end of your Colab, at the end, once you're done, you're going to close the connection. This is to free up resources when done. So remember here, when we imported this toolkit and we've done all these things, it's like you have a motor running in the background. It has been running your queries and whatnot. So you have to close it to free resources when done. So let's do, for example, you can write this if you have your machine, we can import together. You can just write this on your first cell. We import SQLite 3. So this part we've said it's where you bring in the toolkit that you're going to use. This is where you bring this. This is a very heavy library. It comes with everything that you need to be running the databases. So you have to import it. And then the next step is you connect to the database. If it does not exist, it automatically creates it, as you can see here. If it does not exist, this line here will create it for you. Step 3 is to create the cursor. This object is what actually sends SQL. It's what actually sends SQL commands. So as we had mentioned here earlier, we create a cursor. This will be the pen that you'll be using, or rather what will help you write your command, your SQL queries and have them run. So I think I had done this earlier. So as you can see here, once it's connected, it will print for you that there's a connection here. We've already connected and cursor is ready. This is to say that we've already created our database called workshop.db and it's ready now. We can start creating tables within it. This is just the explanation that we've talked about there. Import SQLite 3, it loads the library. The connect, it opens the DB, the current session. If it doesn't exist, it's created. This .con in our connection, in our phone line too, it connects us to our database. Then the cursor, it creates a cursor where we can actually send SQL statements and fetch results back. Think of phone as the phone line and cursor as the person talking. Then we have a step 4 here. Execute an SQL command through the cursor. Create table if not exists, demo. ID integer. Now we are creating a table that is called demo. And we have said create table if not exists. Please note of this. So every time, make an habit of every time you're creating a new database in whatever environment you're using, if you want to create a new database, make sure you use create table and add if not exists. This way it will run through the existing databases to see if there's a similar name that has been used for that database. If it's there, it will tell you it exists. If it's not there, it creates. So in our case, we've said we want to create a database called demo. You remember when we were talking about setting the blueprint. So here we need to add the ID and note, which will be an integer, and the other one will be a text. So every ID that is going to be input in that table is going to be an integer, and every note is going to be a text. So we've set the blueprint for that table. Step 5 is commit permanently, save the changes to the .db file. So you connect, commit, and you submit. In our case, we have used print to tell us that if it has been done or it has not been done. And as we can see, it was created. And then finally, step 6 is to close the connection when you're done. So ideally, what we've done from step 1, we did import the library, and then we did set up the database. And then we did create a cursor to create that we'll use to create our queries. And then step 4 here, we did our first command, which was to create a table within this database called workshop. So our table is called demo, and we want it to have the ID column and the note column. And our ID is supposed to be integer, and the other one is a text. Since we've already created the database and now it has a table inside, we can now commit and save the changes so that next time you come to open this database, it will have this table that you've created. If you don't commit, you will not have this table that you have created. So imagine if you are doing data for a school. You've created the tables, you put all the information, all their details. You've created the teachers table as well, the subjects for.
Sorry, Marty.
Yes.
So somebody is requesting. I don't know if there's a file you're working on that you can be able to share for those who want to follow along by practicing.
Just a minute. I can share mine.
Yeah, is
We
there a
go
file you're
through
working
together.
on currently?
Sorry?
The one you're working with, is there a file you're working with in terms of
Yeah, this is a file. Yeah, this is a file. I can share it.
You can share with them so that those who want to, is there an exercise they want to do? Somebody is asking, I don't know, maybe Marcel is asking if they can be able to get the material so that they practice on the go. I don't know if you get it.
Okay. Yeah.
You can just drop on the chats here. They'll be able to
just a minute. Just a minute. I've sent the link on the chat so we can move together with it.
Okay, that's good.
Okay.
Yeah, Marcel, let us know, and the rest of us, let us know if you are able to, you've been able to open it up and you're able to follow us through. Yeah, just go on, Martin. I think it's
Okay.
yeah.
So in step 4, we've created, so I was giving an example of, imagine you've added all the data for the whole school, and then you forgot to save. So the next time you come to open your database is going to be empty. So it is very important to commit your changes before for every SQL command you run. And then finally, once you've done setting up your database or using your database or doing the querying and whatnot, it is very important to close it to save on the resources. So for this part as well, you'll go through to do a knowledge check quiz, and then there's a small exercise for you here. You can practice on that. So in the next module, we're going to look at creating tables. And this is the simple syntax of creating a database table. We've seen on the next chapter or next modules, we're also going to see, we're going to do a practical one we can do together, or they're already there, we can run together. So you create the table. So you give it the table name, how you want to name it. And then you populate the columns. It depends on the number of columns that you want or what kind of data you are having. For instance, we were doing the students' data. So assume this is our students. Assume this is our students table. So we can create the table name called students. And then we can have the first column is registration number. And then we set the data type as the constraint. And then we have the second column, we have the names. We set the type of data type we have as the constraint. And for your information, this is just on the other course we saw there were data types for Python. So even in SQL, there are data types. So we have integers for whole numbers, text for string and characters. We have real for decimal or floating numbers. We have date. We have Boolean. So every time you're creating a table, you have to set these constraints. This will be the blueprint. So every time someone wants to add data to that table, there's set of rules. There's a certain criteria, that has to be followed to input the data. The constraints are the primary key. We spoke about the primary key. Not null. This means when you set that specific column to be a primary key, that will mean it is the unique identifier of that table. When you set the next column to be not null, it means that at any given point, it can never be left empty. You've seen, like, when you're doing, for example, when you're filling in some forms or you're doing application, and there's some parts there's some parts you're supposed to fill in, and there's a red asterisk up there to tell you that this part can never be left empty. So you can never submit that document without inputting anything there. So that is what is usually done on the background. It is set to not null, so that every time someone has to input data there, they have to put in something. It cannot be empty. Unique values must be different across all rows. This is to mean that there's no repetition. No two employees can share the same email. So that means it's the same case when, let's say, you sign up for you sign up for a certain resource on Google. So you cannot sign up twice with the same ID. So that means every sign up has to be unique. So a unique constraint has been set for every user. So there's no way you can have two accounts. Default, if no value is given, use this automatically. So for example, if we are collecting data from Kenya, so we can put a constraint on the location column, such that if someone is not, or they forget to input, let's say their place of birth, the default value given will be Kenya. So we can set it to that. So every time someone doesn't input something in that column, it automatically assigns it to the word or to the location Kenya. Then we have a check constraint, only allows values that pass a condition. So for example, let's say we are collecting information about Kenyans, and you've been asked to put your ID number. So we can put a check constraint that makes sure, I don't know if that's the best example, but that makes sure the ID you put is a valid ID. So we can put a check constraint on a given column to make sure that a given, or for example, when you're collecting data for teenagers, and on the column for age, you've put a constraint that states that if you're above 18 or you're below 13, we cannot accept your application. So we've done a check there. It will only pass if only your age is between 13 and 18. So that's a check. So let's build our first table. We'll create a students table, the one we've been using for a student management system that will keep building throughout the course. So the very first step that we spoke about is to import the libraries. We import SQLite 3, and then we do a connection to the database. Then we create a cursor. We said the cursor is what will help you do what? Will help you run your SQL queries. So we do you have to start with the cursor.execute, and then drop table if it exists students. So ideally we are saying if this table already exists, we didn't create it, we want to create a fresh one for what we're going to put our data in. So if it has already exists, drop it and create a fresh one. So we do, if you remember where we were doing how to run the queries, we said you have to use cursor.execute, you put the brackets, then you do your query inside. So we do a drop table if it exists, students. This line alone has done a deletion. If there was a table in this database, in the workshop database, it has already dropped the students. So now our workshop database does not at any point have a table called students. So we go again to cursor execute, and we create our student table. So we want our student table to have student ID, first name, last name, age, the grade, the GPA, if they are active in school, and their date of enrollment. and then we save. Remember to save. You save once you've created the table. If you look at this, you can see as we are creating this table, we are setting the constraints. So we set the student ID to be the integer, and it's also our primary key. We've set the first name to be text and can never be a null, so that part can never be empty. We have last name text and it's set to not null, so it can never be empty. We have age as the integer, it has to check. So every student has to have some age. You can never be age 0 and you're in school. You cannot not have been born and you're in school. Then we have grade. It can be text. It should be a text. And the default one is 9th. So every time there's a blank left on the grade column, it automatically assigns to the 9th grade. GPA is a real number, so it means it can take decimals. Is active is Boolean. By default, it should be 1. So if you don't put anything in the is active column, it automatically assumes a 1. And then we have the enrollment date is given to the date. Can do this after that. So when we run this, we have a table that is called students. So this is not very necessary, but we can just check the schema. So as you can see, we have how many? We have 8 columns. And we can see that the constraints have been set. So this is how our table looks like now. Like this. The constraints, everything that we've set, it's like that. But our table at this point is empty. This is the result that we got. Now we go to the next part. We can now create, our table has now the students table. Sorry, our database has the students table. Now we want the teachers table. Remember, we have to start with cursor.execute. Then you put in your line of code inside there. Then you save once you've done. Once you've run, every time you run this, your block of code, you make sure you save. So we can run this. Can just do it up here. So can add a comment there. Save. Oh, sorry. We closed the database. Sorry. We did close the database here. We just and we run it again. Run this again. Yeah, now it has created our table. Sorry, I forgot that we had closed the database here. So after creating the teachers, we can now close it here. Oh, sorry. You see, actually, this is a good error. You see, I have been clicking this more than one time. So the first time it created the table, and I come to try to create it again because because as I mentioned, in every database, every table has to be unique. You cannot have a table that is the same as the other one. So every time you try to create a table that has the same name, it will give you this error. That's why when we were creating, we said if it exists, drop. Otherwise, we will not be able to create our table. So yeah, that's why we are getting this one, but it already exists. So I can just clear that output. So we've done the teachers and the students tables. So the next module will be CRUD operations, and CRUD operations mean creating, reading, updating, and deleting. So these are the most common, or the common operations that you'll be doing on a database. You'll be either creating or reading data from the database, or updating or deleting data. So let's now we'll build the database again, the one that we had built. I believe everyone has this now, so we can just run it together. Remember, the first step is to import, then you connect to the database if it exists. If it does not exist, it creates one for you. And then you use the cursor, you connect to the cursor so that you can start writing your queries. Then before writing any query, remember to tell the cursor to execute, because you're about to execute this line of code. So drop the table if the students exist. Then the next one will be create the table. After you've checked it does not exist, you can now create your table. You set your constraints, and then you save your changes. So student tables is ready now. Now we can now use our table. So we have our first operation, which is create. Create is adding data with insert, and this is the simple syntax of it. So into insert, that is how you add data into your table, and this is the simple syntax. So it is you use the insert command, insert into the table name, the columns that you have, and then the values. In our case, our columns here will be student, first name, last name, age, grade, GPA, is active, enrollment. So the first one, we insert the first information for the first students. Remember not to forget this cursor.execute before you start any SQL query. So insert into students, first name, last name, age was there, and the values will be, so the values now is the information that you input in for the students. So we have Amina Wanjiru, who is 14 of age, 9th grade, a 3.8 GPA, joined in that date. And then you save, then you print. Now we can just print this first one. So now your database has one person, sorry. And remove this from here. So at this point, you can input as many names as you want. You can input all the students' information at once to avoid writing, like starting over all over again. So if you have another student, you add there. Then we have parameter holders. So you can use parameter. If you have very many students that you want to do at once, you can use parameter holders. So you can say students data, and then you have we have Kevin Otieno 15. So you input the rest of the students here, or the whole database, or all the names of the students, sorry, and the information. You put them in a placeholder like this. And that cursor execute many, insert into. So we can take this back there and see if it's going to add. We already put input one student. So to add many students, if you have, let's say 100 students, instead of doing it manually one by one, you can put them in a place, in a holder like this, and then you insert using cursor.execute many into the table, and then you save, sorry, and then you can print. We've already inserted one. Okay. 3 more students inserted. So now our database has 4 students in them. So this is a smarter way of, if you have a lot of data that you want to input. So instead of every time writing like this, as you can see, this is a bit tedious. Imagine for every student you have to write the columns and then the values, the columns and the values. That's a bit hectic. So if you can put them in a placeholder like this, so that you can insert them all at once, it becomes a bit easier. So take note of that as well. So you can go, we've done most of the explanations there as we were doing, so you can go through it. You can go through this once we are done. The next operation is read. So read is retrieving data from the database. As I had mentioned before, you're going to do a lot of selects when it comes to SQL. And if you're going to be working with whatever you're going to be working as a data specialist, you'll do a lot of selects, because most of the time you'll always be requested to retrieve data for this, to combine the data for this, and all this time is just retrieving that data from the database. So the select is a very crucial operation that you'll come across a lot. So this is the basic syntax of read. It's select from column 1, column 2, from table name. But this one means every time you see select all from table name, it means you retrieve everything from that table. It is not a recommended way of retrieving data, because imagine you want to select all from a table that has over 10,000 rows. So imagine the time it will take to fetch that data and the resources that will be used to fetch that data. So it is not a very recommended way to select everything, especially if you are only looking for a specific part of that data. So it's usually recommended you do a select in a selective way where you pick in only the required items within the database. But for our students, since we only have 4 rows, we can just select all from and see. So we can do CASA, execute, select all from students. Let's see if yeah. So since our table has only 4 rows, it's okay to just select all. But imagine where you're dealing with a lot of data, avoid using select all from the database. So casa.fetchAll actually retrieves all the matching rows as a Python list of tuples. We spoke about tuples the other time. Then we have fetch none for a single row and fetch many for a batch. And this is our output that we've got. And then we have the update operation. Update is for changing existing data. For instance, if we want to change, we realize that one of the students' information is wrong and we need to change it, we're going to use update. And this is the basic syntax. So you update, you pick the table name, you set the column and the new value and the condition. So we can see in the example, for example, in Amina, update students, update the table students, you set GPA to be 4.0, sorry, where student ID is 1. So for Amina, since we know from here, she was the first one, I think, here. Since we know this one. Oh, the student ID, sorry. Since we know she was the first, she's the first person to be in the database. So her ID is basically 1. So where student ID is 1, we update her GPA to 4, which was initially 3.8. So we can see here. And then we save the changes. Don't forget to save the changes. And then we select. Now we can select from students where student ID is 1. And then we can see now it is updated to a 4. So the update operation is used to change existing data to the new information or the updated information. Delete operation is removing data. This is where you remove data from a table. Let's say a student has left the school and you want to remove the information from the table, you use delete. So delete from the table name, condition. Let's remove, Brian has transferred to schools. Let's remove his school. So CASA execute, delete from students where student ID is 4. Then you save changes. Then you select CASA execute, select all from students. Now we can see how many students we have. Now we have 3 students because we have removed Brian to another school. So generally, that's about the operations that the CRUD operations in SQL and how they are used. You can try the quiz and the coding exercise afterwards when you get time. Module 8. We move to module 8. In module 8, we're going to do filtering of data. Filtering of data is what I was mentioning when we were doing the example for customers and orders. So when you want to get a certain customer and how much they've been spending in your store, you have to filter through the tables to fetch a specific or a required type of information from the database. So that's filtering. Okay, let's build a richer students table so our fillers have something interesting to work with. Okay. As usual, we'll start with importing the library, and then you connect to the database, and then you connect to the cursor so that you can start writing your queries. And then we create our table again. If it exists, we drop it. So we've dropped the existing table. Now we have a new table. We are creating a new table. And then we store our students' data now into this variable. Then we're going to insert all of them together. So when we do like that, our student table is ready with 7 rows. Now let's start filtering. We are using where, the foundation of filtering. So this is the basic syntax of using where. So select columns from table where the condition is met. Now, don't forget to use cursor.execute when you're writing your query again. Although in the other databases, you won't need to write this cursor.execute. This is specifically for Colab. When you're using the other ones, you just query it directly like this, just like that. So cursor.execute, you select the first name, age, grade from the table students, where age is 14 and grade is 10th. So we only want students who are of age 14 and above, and they're in grade 10. So this is how we filter from our database. So the only students will be Kevin and Lucy. So I hope you've seen. So where is where you give the condition. So you can be told select customers who have purchased items that are worth more than 10,000. So the where will be where buying price or buy the cost or the price is greater than 10,000. And then it gives you the result. So here, and, or, and not. You can use, and is used when two conditions are together, or is when it can be either of the conditions given. And not is when you're not meeting that condition. For example, in or, we're going to say select the first name, city, and city from students where city is Nairobi or Kisumu. So in this, we want to select students who are from either Kisumu or Nairobi. So we can see Amina from Nairobi, Kevin. So we want all the students, either if you're in Nairobi or if you're from Nairobi or Kisumu, we want to retrieve that information. So either of the two, we can pick those ones. And then we have not. This is excluded rows matching the conditions. So given a certain condition, so the ones that don't meet that condition is what we want. For example, select name from students where city, not Nairobi. So anyone else but those from Nairobi. So if you're from Nairobi, we don't want your information. So as you can see, no one is from Nairobi here. These are from Kisumu, Mombasa, Eldoret. So not is to exclude the rows that are meeting a set condition. And then we have like, this is for pattern matching or text. So for example, this one, the first one, if it's M and this, the percentage symbol is to mean you're searching a text that starts with M. As you can see where this percentage symbol, I don't know what it's called, the percentage symbol where it lies. When it comes after the letter, it means you are matching with a word that starts with that letter. If it comes before, it means a word that ends with that letter. If it has two in between, it contains an OE anywhere, like anywhere within the text. If it has these two existing, it should retrieve. If it has an underscore and A, the second letter is A, exactly one character. So like, yeah, like the second letter, you remember here, we were starting this is the first, starts with an M, but here we've added an underscore there. So it means the second letter, not the first letter. So this is for the first letter if it does not have an underscore, but if you put an underscore, it means you refer to the second letter. So if the second letter starts with an A, you're supposed to retrieve that. From our database, from our table, sorry, we can use our example. Select first name, last name from students, where last name, like the last name now, like it starts with a name. So the name, if your last name starts with a name, we want to retrieve that information. And you can see it's Grace Mombi. So you see, Mombi starts with an M, Mwangi starts with an M. So that's how the like pattern matching works. Then we have in is for matching against a list of options. So in our example, select first name from students where city in Nairobi, Mombasa. So instead of city, Nairobi, or city, Mombasa, we can write it more cleanly like select the first name from student where city is in. So we want to retrieve for students who are in Nairobi and Mombasa. So instead of using or, you can use in, especially if you know, if you are certain of the two of the cities that, or the values that are already in that existing column. So you can use or, you can use in, sorry, instead of or. So the two, I think they are used in that, you can interchangeably use them. So for example, so Amina from Nairobi, Grace, Nairobi, Faith, Nairobi, and Peter from Mombasa. So it has selected all the students who are from Nairobi and Mombasa. And then we have between. Between is for matching a range. It includes both ends. So both ends means if it starts from 1 to 10, it will include even 1 and the 10. So select first name, GPA from students where GPA between 3 and 3.8. So it's for students who have a GPA that starts from 3 and ends to 3.8. So not where, not we're still using where to give the condition, and then between to give us the range that we want to use. Then we have distinct. Distinct is, as just the literal meaning, is for removing duplicates. So select distinct city from students. So this one is going to remove duplicates from the results that you're going to get. You see, so we are selecting the distinct cities. So all the students, they are from either Nairobi, Kisumu, Eldoret, or Mombasa. So regardless of whether we have 5,000 rows of data, it means in the city column, then the value can either be Nairobi, Kisumu, Eldoret, or Mombasa. Those are the only existing cities within that column. And then we have order by and limit. So to do the example, and then I give you the explanation. So select first name GPA from students table, the table now. You order by GPA, descending limit 3. So order by GPA descend sorts the rows from GPA from the lowest, that is from the ascending to the default if you omit descending. So by default, if we did not use this one, sorry. Sorry. We have to run this again. when you remove descending, you remove the condition for descending, they automatically arrange from the smallest to the largest. But when you include, it arranges now from the largest to the smallest. So order by GPA, you select the name and their GPA, and then you order by a certain value. For in our case, we are ordering by GPA because maybe we want to know who has the greatest GPA, who is the smartest in the class. And then limit means you give me only the top 3. So you can put a limit of 10. So in this case, we only want, let's say we wanted to get the top 3 performing students in the class. So we get their first name, their GPA from our table, and then we order by GPA, and then we order by descending so that we can get the highest, from the highest ranking to the least ranking. And then we cut at number 3 so that we can get top 3. If we wanted to see the poorly performing, then we remove this, we remove descending so that they can arrange from the smallest to the largest. So this is a summary of what we've been talking about. You can go through it at your own time, do the quiz, and there's a coding exercise there that you can work on. Then we go to SQL functions. So far we have done sorting of our rows in our database. Now we're going to build another database for employees. Sorry, another table for employees within our database. So as usual, don't forget to import the libraries. You connect to the database if it exists. If it doesn't exist, it will create one for you. And then we connect it to the cursor, and then we check if the table exists. If it doesn't exist, we create our own. And this is what we've done. And we've collected all the information for our students and put them in this variable called employees data. And we've loaded all of them to our table. So the table is ready to use. So for functions, we have functions in SQL, they're used to do summaries. Now, in most of the times, if you get a job, or when you're going to get a job in company X, when you do, most of the times your managers will be wanting to know or requesting for a lot of summaries from the database. For instance, the sales manager will want you to do a summary of how much the team has sold within a given period of time. They'll want you to know to do a ranking of who is best performing, or which item is selling most, or how generally the company is performing. And that is where you're going to do a lot of, or use a lot of functions. So the basic functions are count. This is to count how many rows. For instance, you can count how many customers visited our shop today. You can check from the database. You can do a sum. You can do a sum of how much have we sold today. So instead of doing things manually, you do a sum function, and it will give you the summary of what was sold today. You can do an average. Let's say for the last 3 years, averagely, how have we been performing? You use the average function. You can use the max function to check the largest value. You can check per day which was the highest or the item that sold the most. So you use the max. Or you can check the minimum, which item was valued the least for that day. So that's how you use functions. Functions are generally for summarizing the data in your database or in your tables. Let's do this one by one. Can execute this. So in this, we want to count all the employees and we print. So the total number of the employees is 5. 1, 2, 3, 4, 5. So the total number of employees that are in our table are 5. Then we want to see the salaries that, so select sum, so we add the salary from employees. So we want to know the total salary that all these employees are paid. So how much is the company spending on salaries? So we do select, you sum everything on salary from the table that we created called employees. And then you can print the salary there. The next one, you can check the average salary of the employees. So in average, how much is each employee getting? So select average from salary from employees and you print. So on average, each employee is getting at least 61,000 shillings. Then we can do a max salary and a mean salary from employees. So we can see who's paid more and who's paid least. So the highest paid is 72,000, the least paid is 49,000. So those are the common functions, the basic functions that you're going to come across when you're doing databases. And then we have the round function. This is for controlling decimal precision. For example, select round average salary this is to say two decimal places. And when you run, is it 2 or 1? Select average salary 2 from employees. Just a minute, I check on that. The round function. Yeah, this is supposed to be the decimal places. Oh, sorry, it rounds to supposed to round to 2 decimal places. You can check that, but ideally, the round is supposed to round to the number of decimal places that you want. Next is the string functions. When you were doing Python, you saw when you were doing string functions to convert. So the upper function converts to uppercase. The lower function converts to lowercase. The length counts the characters, like how many alphabets does the name have? So it counts the length. The substring extracts a part of the string. So we can do this separately. We see how it works. So select upper, the first name, and lower from employees. So we want to convert all the first names to upper and all the second names to lowercase. So as you can see, it appears as Amina, 10. All the first names now are in uppercase and the second one is in lowercase. And then we can count the length of the first name. So select first name and then we check the length. So we select the first name and then we check the length. So Amina has 5 and we can count is 1, 2, 3, 4, 5. For Kevin, the same, the Grace. Yeah, so that's how we use length. And then we can select a part of this string or a part of their names. So select substring from first name 1, 3 from employees. So it's going to pick the first 3. So this one, when we were doing Python range, this is like range. So from the first character to the third one. So it picks the first 3. Then we have Coalesce. This is for handling null data. So notice Grace has no email on file in the database. Coalesce lets us substitute a fallback value. So when we run this, select first name, Coalesce email, no email on file from employees. So Amina had an email, Amina, Kevin, Grace, no email on file. So this function helps us to identify or to deal or to handle a missing value. So instead of returning the value for Grace with a blank or just an empty space, it gives some information in it. So usually without this function, Grace will just have come with a blank here, just nothing, not saying anything. So when you use this, we are able now to tell if certain person has not given us a certain value, this is what you're supposed to return. So if there was a missing value here, this is how you're supposed to return instead of returning a blank, which makes more sense in a business setting. Instead of getting results with a blank, it's now informing you that there was no email for Grace that was given to us during the setup of this database, which is more informative than just returning a blank. So on that module, you can do the quiz and do the coding exercise as well. And then we go to module 10, where we're going to learn about grouping data. So we're going to start by group by, and this is the first syntax. So group by, it splits your table into buckets before applying an aggregate function to each bucket. So you remember we've done the aggregate functions up here. We've done the aggregate functions up there. So group by is like you're splitting the data, and then you apply the functions on the split data. And this is the basic syntax. So when you do an example, it will be easier to grasp. So you select the column that you want to group, you apply the function, and then you select the table, and you select the grouping column. Now, let's do on an example. So you import, we connect to our database, we connect to our cursor, and then we use a group by function. So select department, you count all as number of employees. The average salary, you remember these are the functions as average salary from the table employees, and you group by department. So when you run this, you've counted the number of employees, and you've done the average salary of the employees, and then you've grouped by each department. So our group by here, our group by function is for grouping employees in each department. So what we've done is we've separated all the employees and grouped them into their specific denominations. So if it's engineering, marketing, and sales, so we've split them. And then we've done an average of the salary of each group is getting, and then we count them. So we did an average for all their salaries, and then we counted them. And then, we first grouped them, We counted them and then we did an average for all their salaries. And this is what he has returned to us. So in engineering, we have 2, that's the average salary. So ideally, that's how grouping works in SQL. So it splits your data into buckets, and then it can apply the functions that we've seen earlier, like average, sum, and such on the grouped data. Then we have the having command. It's for filtering groups, not rows. So we've already seen how to use where. So where filters individual rows before grouping happens. We saw how we were using where and how we were using conditions in applying the conditions after using where. So where you use where when you're about to apply a given condition. But what if you want to filter based on an aggregate result? For example, when you've done a grouping, how you've grouped the employees in their departments, like only show departments with average salary of above 55,000. So in that case, you can't use where, because where is suitable when you're only dealing with rows. Having is for filtering a group that has, or a grouping that has already been done on a certain table. For instance, we are going to do select department average salary as average salary from employees, and then you group by department, and then you're going only to select the average salaries that are above 55. So after the groupings we did here, we're only going to select the ones that are above 55. So when we run, the only that are above 55 is only engineering and sales, as we can see here. Marketing is way below that. So we filtered out marketing by including, having, and setting the condition of the average salary to 55,000. The next module, we're going to look at joins. We're going to look at joins. I think this is the final module, I think so. So we're going to look at joins. If you remember when I was showing you primary key, foreign key, and how tables are connected. So sometimes you might want to retrieve data from multiple tables that are connected or related to one another. So what you do a join. So how a primary key and a foreign key relate, and how you can retrieve data from different tables within a database, that's where joins come in. So we can first set up 2 related tables. So in this case, we're going to use the customers and the orders table. So we create the customers table and we create orders table, and then we insert some data into them. By now, I hope we are together in how we create a table before. Sorry, we connect to a database, the basics ones here. I hope we are together in that. We have done lots of that today. How to create a table and how to add the data within a table. I hope we are now together and at least you grasp that in this part. So we create 2 tables that are related to each other. As you can see here, the customer ID here is the primary key. And in order ID is the primary key here. And the foreign key is customer ID here in the order table. That references the customer ID, which is primary in the customers. And then we insert our data. So the first join that we're going to look at is the inner join. So the inner join only matches rows from both tables. I think I can share some images. Let me see if I can share an image to make it clearer. So the inner join only returns the matching rows from the table. See if I have a better image for that. Yeah. So let me just add the image here. Sorry, can you see the image?
Yes, we can see it.
Okay, thank you. So as I was saying, we are talking about the inner join. So this is the inner join. So inner join, it will only return the similar rows in A that are the same as in B. So that's what is called an inner join. An example of a query will be select all from A, inner join it on B on A key is equals to B key. So these are the keys. The keys here mean the primary key and the foreign key. So you select from table A, you inner join it with table B on A key is equals to B key. So where the two keys are here, for example, here, where is it? Here, these keys now is what joins them together, and it's what you reference on how you're going to join them. So an inner join basically joins two tables, and it only returns the tables that are similar from both tables. And in our example, select customer name, order item, and the order amount from customers. Inner join orders on. So we've basically selected all the columns that we want to return. And then we selected from first customers, and then we want to select from orders. We want to select from both tables, but we have to join our customers table and our orders table. And the only place that they come together, it is where the table and the ID, and the other table and the ID where the key is common. So our common key will be customer ID. So when we select from customers and we inner join on orders, where the key on this table, our customers, the key was customer ID, is the same as the same key on table orders, this key. I don't know if I'm making sense, but ideally is where you give the condition, see the condition, sorry, not the condition. You give the keys, which key in this table equates to this key on each table. And we've seen the customer ID on customer's table is what equates to customer ID on the orders table. So that's how you inner join. So the more you'll do practice on it, the more you'll be able to understand. So on customer ID, tells SQLite how the table connects. So you have to give it a connection, and you have to specify the kind of join that you also want. So next we have a left join. In a left join, this is a left join. So a left join, as you can see, it returns everything in A and part of B that matches A. So like this, all rows from the left table, matched or not, are pulled. So as you can see, everything on A has been pulled. So this is the syntax: select columns from table A, left join table B on table A, the key, and table. So in our database is going to be, our customers table is the one that is on the left. So our customers, select customer name, order item from customers, and you left join on orders on where they match. So left join keeps every row from the left table, even if there is no matching row in orders. When there is no match, SQLite fills the right table columns with none or SQL. So ideally, you're going to return everything in the first table. This one, it has given us everything on the first table. And then we have a right join. A right join looks like this. It returns, it is the opposite of the left join. It gives everything on the left side, regardless of whether there's anything matching on the right side. So when we do select customers, it will give us everything on the left side, regardless of whether it is ideally an opposite of the right join. And then we have the full outer join. A full outer join joins all rows from both tables. Matched rows combine plus unmatched rows. So it's everything. Full inner join. Full outer. I don't have full inner join here. Sorry, full outer join. This one. This is the full outer join. So the full outer join joins all rows from both tables. Matched rows combine plus unmatched rows from. So so it will pick all the rows from all tables, and then it will combine the matched rows to return as one, not like two different not two different datas, but all the information that is similar, it will be combined, and then it will be returned together with everything else on the other tables. So that's the full outer join. And then we have a cross join. Honestly, I've never used a cross join. I saw it today when I was preparing these notes, but we can run it together and see. So a cross join pairs every row of the first table with every row of the second. No on condition needed or allowed. With 4 customers cross-joined with themselves, that's a 4x4, giving 16 pairs. We use limit 6 to put the output to keep the output short. Okay, so it pairs every row of the first table with every row of the second. It is across. It is like multiplying the number, or the number of rows in this in table A and B, and then you give the result like they have done here. If table A has four inputs and B has 4 inputs, so the total number of results that you're going to get will be 16. And then we have a self-join. A self-join is joining a table to itself. So it's useful when a table references other rows within the same table. This is a classic example in employees referencing their manager, who is also an employee. So if you're doing a reference within a table, for example, in employees, you want to refer who is your manager, but the same manager is within the same table, then that's a self-join. Let's do, so we create a staff table. We have done the employee table, so we can now do the staff table. We create the table and then we input the data. And then we select employee name as employee, the manager name as manager, from staff as employee, and then we left join staff as manager on employee. This is a left join. I want us to do as a self join. That's a left join. I wanted a self join. Right. Because of time, you can go create more data and just try out the joins and play around with them to be able to get it further, and then you'll be able to understand why and how you choose which join to use. How you choose which join to use depends on which relationship each table has with each other and what type of information are you looking into sourcing. So depending on all those, you'll be able to know which kind of a join are you going to use. So you can go through that as well, and you do the quiz and do the exercise as well. So in this module, we're going to look at database design or normalization. So normalization is the discipline of organizing tables so each other is stored exactly one place. So you structure tables and relationships to reduce duplication and prevent inconsistent updates. So when you're talking about something like normalization, don't think about small tables like the one we're creating. Think about an organization like Coca-Cola that has massive amounts of data in their database, and imagine in each database there's a duplication. If it's in the order ID, in the order table, there's a duplication and of another input in, let's say, in the customer table. So imagine every time there's an update that is being done on the customer name, and it has to be updated on every other table. So without normalization, it becomes like a bit waste of resources to maintain and to update the database. So normalization is very important when database design, when you're designing database. So in when we are talking about relationships, when you're talking about relationships in databases, there are very many. So normalization comes in to reduce redundancy within the tables. So you try as much as you can to give the most relevant information in a given table and to make sure it relates to the other, but at the same time, make sure that you have not repeated yourself so much within the tables. As much as you're maintaining these relationships, you make sure that it's the only relevant data that is going to be required within a given table to maintain a certain relationship with another table. So you avoid duplicating yourself so much or repeating yourself so much. So there are many types of relationships. So we can have we can have one table. I mentioned that you can have one table that has more than one relationship or more than one key relating to another table. So you can have one to many. This is one row in table A can relate to many rows in table B. But each row in table B relates only to one row in table A. For example, when we were doing customers and orders, when we are doing customers and orders, is only the customer ID was appearing in the order table. But then you can realize there might be another input within the order ID that also relates to the customer, but the only relationship, the only connection that holds them is in terms of the customer table is the customer ID. But in the orders table, there are more than one that you can reference to the customer table. So that's how we call to one to many. So when it comes to the customer table, we say it has a one to many relationship with the orders ID. And then we can have many to many, where rows in table A can relate to many rows in table B and vice versa. So for example, the students and courses. So one student can take as many courses, and one course can be taken by as many students. So between courses and students, you see, there'll be many relationship because one student is allowed to take many courses. So it can relate, the relationship becomes a bit wider. And at the same time, one course can be taken by more than one student. So now that becomes a many-to-many relationship. So this is when you're designing a table, most of the time you'll be told to do an ER diagram. An ER diagram is an entity relation diagram. It shows you how tables are related. For example, if this one is pointing here, the customer ID, this is the primary key here, but it's a foreign key here. So the primary key points to its foreign key in the another table. That's how these two are related. And then you come to products. The product ID, the primary key here points to, it becomes a foreign key in this other table. So these are related. So ideally, when you want to pull data from this table at once, you can come up with a query that can query from the three of them because there's a connection. So I think I've come to the end of it. This is a mini project at the end that you can do afterwards on your own time. This is not the one that we'll give you as a group because I've shared this file to everyone. You can go try the quizzes and the practice exercises that are from after each module. You can try this mini project during your own time for practice purposes. There's also a cheat sheet, I think, at the end of this. At the end of it, there's a cheat sheet that can help you. Yes, I put a cheat. No, there's another cheat sheet somewhere of challenges. Yes, there's a cheat sheet at the end that can help you go through the summaries of what we've done today. And then there's a bit of so much summary at the end, a lot of practice questions that you need if you want to go through them again. There are a lot of practice questions at the end of each module. You can look at them at your own time. So I think I think time has really gone right now. So I think tomorrow we'll have group 2 and I'll share with you the challenge that you can do as a group, and then you'll be given an email where you can submit, and then we can have a look sometime next week and I'll give you a feedback. But as for now, I think I've come to the end of this presentation, and thank you for listening to me. I hope it has been, I hope you've learned something from it. I know we have gone past time, but yeah, thank you.
All right, thank you so much, Helen. We appreciate the training. Let's appreciate the training that we've had. So yeah, I think there's just a question on the group. What is it? Can I do practice via my SQL instead of SQLite?
Yes. Well, the reason we used this is because we were avoiding to do a lot of installations to take much time. But I mentioned that this was the easiest way to do this. But at the end of the day, if you have grasped on or you are able to come up with SQL queries, you can use on whatever platform you feel like. So yeah, you can use there. Actually, I will share with you the setup that I wanted everyone to try on so that they can just practice. And then I wanted you to do on Postgres SQL, because on that you can go to the app and open and see how you populated data. You can see the ER, you can create an ER and see, and it will make much more sense that way. So yeah, you can practice there. That's totally okay. Can you send it in WhatsApp? I can't see the document. Okay, I'll add this to that the other folder that you are sharing. So I'll put everything there so you can just check there. How can I get a list of variable names from the database like we do in Python or R? How can I get to have a list? So when you go through the document that I've shared that we were using today, it's like a placeholder just to put in information of what you want to put in the database. And then it is to make it easier to upload data to the database. Because if you are going the old way you have for each entry, you have to input, let's say, all the column names, and then you add the values one by one. So instead of doing that, let's say you want to transfer this data from an Excel sheet, you can copy the names from the Excel sheet, you arrange them, and then you put them into that variable, and then you upload directly. So when you go through when you go through that file, you'll be able to see how we did it and why we did it. So it is due to create. We only create it when we want to upload huge amounts of data at once. Are we going? Yes, please reshare the link. Okay. Can you send by WhatsApp? Okay. I think.
Hello, man. Training Mati Mosane. Why not you kasa gochun?
No, I don't think tomorrow we have a lesson unless we arrange for another webinar, but I think Levix will take it from there and answer the rest. So we have not covered the regex-p operators. This webinar was basically to go through on the basics of SQL and what to expect and how to just to spark some curiosity in you, and also to make you understand or know what to expect when you start handling SQL. We cannot cover everything in one session. There's a lot of things to learn in SQL. We only did the basics. There's a lot of things that we so if you want to do everything and to cover everything, I really hope you're going to sign up for the classes in Databrid. And in there, we can meet there and do much more in SQL and in Python. Yeah.
Yeah, thank you very much, Helen. Thanks for taking us through the session. It was very nice. You've covered quite a lot over a short period of time. Yeah, so we do appreciate. Also, we appreciate everyone who stayed through up to this point. Believe all the questions have been answered. We don't have much time really, but we've covered whatever we're able to cover within the short time we've had. Yeah, so if you think you have interest in the areas we've covered or other interests in data, data is actually very broad. Whatever we've covered the other day and today have just been Python and SQL. These are some of the very important bits in data. Pretty much all data professionals use those two tools in some way. Whether you're a scientist, whether you're an analyst, whether you're an engineer, whether you're even cybersecurity professionals within various sectors, they use these tools. So that's why we said let's focus on this tool within the small time that we've got. So yeah, thanks for your concentration. There's supposed to be, the material has been shared by Helen, and I think you can be able to access it. There was a Google Drive link, right?
Yes, I'm
Yeah.
adding it there to the drive and then I share again.
Also, they'll get everything from that.
Yeah, they'll get everything from there, yeah.
That's okay, thank you. So somebody's asking, can you have a session also looking at basic Excel? Yeah, okay, we do have these trainings from time to time, but then within 2 hours, you're not able to get trained on everything, ideally. We just cover the basics, we just cover the areas. That's why we see we have to move even with speed just to cover at least some reasonable size of the curriculum. But really, 2 hours or even 1 week or 2 days cannot allow you to cover even just one tool alone. So we encourage you to join the group, to join the full program, just as Helen has highlighted. The full program is 6 to 7 months, and it has modules. So you can choose to do data analytics alone. You can choose to do, business intelligence alone. You can choose to do data science. There's all that. There's quite a lot. I can assure you that whatever we've covered today is just a tip of the iceberg, and just a small portion of, a small portion of some of the things you'd want to cover in data. So there's a whole program that we have. There's a group which is winding up on data now. We already have the September intake open. So we're already doing intake. We're already enrolling people for that particular program. And the whole program is about 7 months. It has 3 modules. It also costs you only 40,000. That is if you buy the whole course at once. However, if you don't want to spend a whole 7 months learning some things that you may know or some things that you feel are not so relevant to whatever you want to achieve, you can also choose to pick the module that you feel works for you among these options that we have here. So the first option here is data analytics. This one runs for 2 months. This one is going to focus on Excel. Marcel, you've asked about Excel. I think this package would, suit that particular request of yours. You can be able to join this. It's only 2 months, and you have intensive training in the evenings, live classes where you'll also have enough time to practice together with the instructor, and you'll have enough projects to be able to work around and get trained. So you'll cover, of course, that Excel. You'll do cleaning of data, exploratory EDA, EDA. You'll do statistical foundations, SQL, what you've covered here, part of it. You look at data storytelling. You look at Python for data analytics. Then of course you'll have mini projects in there, and you'll also have a capstone project. And just as I explained yesterday, the projects you have, you can be able to add them even into your portfolio, because the projects are real world, especially the capstone project. It's something that you can be able to add even into your portfolio. So of course there's that. Then if some of us are really good with Excel, they're good with perhaps SQL and so on. So if you feel you're good in that, or maybe it is not, you have more need maybe around business intelligence than the other areas, then you can also pick this module too. This one runs for also 2 months at a cost of only 15,000. And, here we're going to be looking at the BI tools, looking at Power BI, looking at Tableau, looking at data analysis expressions and modeling, looking at interactive dashboards. Those dashboards, the dashboards that are able to give you the real-time analysis and report and all that. You're going to look at KPI design and reporting, all these things, business analysis and so on. Then, of course, there's a capstone project for that. So that is if you want to get into the world of business intelligence. It's also a very good area in technology. And I think up there, I'll go back up there. But the third one also within our data stack is the data science and machine learning, module. This one now runs for 3 months because it's a bit more complex. We're going to be looking at Python for data science. So we realized that Python is both in data science and we that's why we also decided to work with Python for this masterclass, because it is not only used even in data, but even other people, even developers and all those kind of things, they use Python for whatever purposes. It's very useful in majority of these tech professions. So there's that. You're going to look at ML. You're going to look at deep learning, all those things. And of course, there will be a capstone project at the end. So whatever fits you, if you feel you want to take up the whole course, you can take it up at only 40,000. However, if you're taking the individual modules, you take it at 15,000 for the first two and 20,000 for the second one, as you can see here. So if you feel these are areas you'd want to explore, we are happy to help you out. And yeah, the classes are, of course, in the evening. So if you're working, if you're busy in the day, you have the evening to get some training. And of course, the classes, all of them are recorded. And once you join, you get enrolled into the CRM. So where the LMS, where you're able to get the material, you're able to do your trainings, get your recordings, whatever it is, interact there, all those kind of things, you'll be able to access them over there. I don't know if there's any question from any of us or anything somebody wanted to maybe learn. There's the group bit. Before I allow you to ask a question, we're supposed to have some group work. So because of time, we're not able to do it here, but then Helen will share with us the material tomorrow so that we're able to group you up. I just don't know how we will get people for the groupings. Is there any one of us here who is here and is not in the WhatsApp group? Because I think that's a more centralized platform for continuous communication. Anybody here who is not in that WhatsApp community or WhatsApp group of ours? Okay, Joyce, Kagongo, Marita. Okay. Let me just share the link again. The link is already on the chats, but let me just reshare. Just click it now and join. Just click it now kindly and join, because that is where we will be sharing the communication. You will get some communication on email as well, but we may not be able to send you emails every hour or every minute. So WhatsApp is usually much more reliable. So Joyce and Merita, I've shared the link on the WhatsApp, on the chat here. Kindly access it and just click, and then you can join. The admin will just let you in. So just join it. We will be able to share further communications from there. But yes, Helen will share with you the communication tomorrow on what we're able to do as a group. So I think we will allow you guys we will group you in probably, maybe, Helen, maybe 3, 4 people or 5 on the max. Huh? So we'll group you 3, 4 people or 5 people maximum, and then you'll be able to do whatever project that's going to be shared with you tomorrow. And then we can look at it next week. This is a free training, so we've not charged anybody for this particular program. We just want to also, this is part of our CSR program where we want to be able to offer some trainings and just enable everyone to get access to these particular skills. And that's exactly what we do them. But however, we're not able to do them for long. The long ones are paid for, just like the one I've shared. So yeah, if you have a question, feel free to speak up. On top of that, on top of the data bit, any question, just feel free to unmute or speak or type in the chats. I'll be able to respond, or Helen will respond. So yeah, there's that data course that I've shared. This one here, which is part of what you're doing today. So before you join this, the moment you click into the link that I've shared, the course link, you will be taken to a page where you'll key in your details. Then immediately you'll be able to take up an assessment. That assessment is not to disqualify or anyone. It is simply to enable us know exactly where everybody is, so that we ensure that we help everyone, based on where they are. We don't want to assume that we know everything, yet maybe we are behind, or we don't want to assume that we are so behind, yet the things we know. So it's just to enable us also to ensure we sort out our cohorts in a more efficient way. So I've typed in the course links. So once you click in there, you'll do your details, your name, your email address, and I think phone number. Then after that, you'll now start the assessment. It's an assessment that you can do within about 10 minutes max. It's very simple. So do the assessment. For both courses, there's an assessment. Once you do the assessment, of course, you will be able to get even a communication from us on how to proceed. That is if you're interested in the long courses. If you're interested. If you're not interested, just ignore the assessments. However, if you're interested in the long courses, where you want to be certified in data analytics, you want to be certified in data science, you want to be certified in business intelligence and machine learning, you can be able to join up that course. Anything from any of us? Maybe you can tell us for those of us who are devices, you can tell us if you've managed to do anything, if you've made any progress. Marcel, your hand is up.
No, thank you. Just inquiring, in terms of the certification that you'd offer, it's accredited to what, could I say, bodies is?
So our certifications we are accredited by the various tools, of course, by the government, and then also there are also those bodies which are not managed by the government. If you look at things like Microsoft, for example. So when you're doing Power BI, that's a Microsoft product. So you need accreditation from them, then it means you're going to be certified. Your certification is recognized across. I hope that answers your question. Joyce Kagongo. Joyce, I don't know if you raised your hand now. Sorry, Marcel, you're saying something?
I'm saying thank you. I think that answers my question.
Okay, great. All right. Any other question? Joyce, you have a question? Okay. Anybody else with something to add?
I did have a question.
Okay.
No question, just a comment that I think I came in few minutes ahead of the class, but the lessons were very well explained by Miss Marty. Thank you so much for making it so clear. I think it was in a pace where it was not fast. It was just flowing. So I appreciate. Thank you.
Yeah, thank you for that feedback. Helen, Marty, we appreciate. You can hear us, huh?
Yeah. Thank you. I can hear you.
Right. Thank you for the training. I think there are also some of us who have joined from even beyond the borders. There's feel welcome. So yeah, we appreciate you guys for being here. Just ensure that you're part of the group so that you don't get left out in any form of communication. And we'd be very happy to have you in the larger program. At least that one you'll have even much more time to be trained in data, and you'll be able to come out as, as a full professional. Yeah. So for those in cybersecurity, also there's another course for that. This one is a bit higher in terms of cost, 52K, of course, and it has modules over here. But then this one is taken as a whole. You cannot break it down. So there's that. If you want to also invest your time in this, you're welcome to be part of it. Yeah, so I think that brings us to the end of these live sessions. Whatever we'll have from tomorrow is just the group work. Marty has shared with you the material. You can be able to go through it. Very important. And I think we'll also be able to share with you the recordings, hopefully tomorrow, so that you can go through them. And if you have any question, if you need any form of assistance, you can be able to reach out to us. Let me just type in my number on the chat if you wish to reach out. So I've seen some of us have already taken even the assessments from yesterday and the other day. So we hope that we can be able to proceed from there. So just type in my number on the chat. 3. So the first one is my direct line. The second one is the company line. You can use either of them. Yeah, sorry. So you can use either of them. I've typed in all that. My email is also here. If you wish to use whichever of them. Guys, we are happy to have had you here. And we appreciate your time. We appreciate your input as well. Matty, okay, before that, Florence, you have a question or something to add? Florence Geruto.
Hi. So I typed in my chat my question, but maybe I can just maybe you've missed it. I had a question about professional bodies. I don't know if there's any in Kenya that's active for data analysts.
Oh, sorry, I think I missed your question. You're asking in terms of professional bodies. Come again so that I get it well.
Yes. I'd like to know if there's any active professional body for data analysts in Kenya.
Yeah, I think bodies are there. I don't know if Helen, you'd want to respond to that.
Sorry, what?
She's asking of professional bodies for data analysts. Professional bodies. So I think when you say professional bodies, there are several bodies, yeah, but then I'm not very sure if there's one specifically for data analysts. But the thing that comes close is we have got communities. We have tech bodies, but then we've also got communities for data professionals, where you can be able to join and learn with people, interact, and get opportunities out of those places. I think that is what I can be able to confirm. Helen, unless you have any addition or anybody in the call, if you know of bodies specific to what she's requesting to know.
I'm not sure if I've not heard of a body in Kenya. It's only communities that I hear of.
Yeah.
I think the only one that I think it's close to what she's asking. It's a body for statistics.
Okay.
Trying to remember the name.
And by the way, Florence, are you asking in terms of a regulatory body or a body that, are you talking about in terms of a regulatory body or a body that manages, teams?
No, not really. Not really. It's a group of professionals. You see, like Ithaka.
Okay.
Yeah, where professionals come together, networking and all that, training.
Okay.
Yes.
Okay, so what I don't think I've come across a particular body for data analysts, and I'll be honest. And probably if they are, they're very few, and maybe they are not so visible. But then what I know is we have communities. Even DataBuild Africa, we have a community where you have data professionals, you share opportunities, you train together, you assist one another with assignments, with projects, and all that. So that is there, but it's not a body. We are not a body really. And I don't think there is any, I've not come across a body. If there was, I may have seen, or Helen or the rest of us may have seen. Or maybe you heard of one somewhere you want us to see?
Not really. I wanted to join one if there is any, but it's okay.
Okay. Yeah, we'll check if there is. I think we'll be able to share. Somebody's saying there's a Statistical Society of Kenya. Okay. Let's see what that looks like. So this is probably more of statistics. I think the traditional statistics sort of got consumed by data somehow. But let's see what they have. Okay. So, okay. They seem to have a conference later in the year. I'm trying to see what they cover really. SSK International, something of, okay. I'm trying to see what they measure in. Is it just statistics or does it also have components of data? So maybe Florence, you can be able to check this out
Just
maybe at your own
first,
time.
the first two paragraphs are actually explaining that. Just scroll back up, but I've seen it's mostly by statistics and biometrics. The first paragraph, just there.
Oh yes, thank you for that. Oh, this one here. So any person with bachelor's degree statistics in okay, biometric, okay. So this is more of statistics. Of course, statistics is still, by the way, is still part and parcel of data. Actually, even the data analytics course, it has a statistics unit in it. But then you see there's the traditional statistics and then there's statistics that we've modified into just to fit into the modern ecosystem. So I think this one is more of statistics and not really data, but it's not far away. So
It's
Florence,
there.
you can
There's
explore
the
this.
second paragraph. It encompasses all that.
Okay. It has all this. Okay. So Helen, you can, I mean, not Helen, but Florence, you can check out this. I think it might be close to what you're asking. Thanks
All
for
right,
sharing.
thank you.
I think that was, thank you. That was Kipruto, no. That was Kipkiri Rono that shared. Thank you. Okay, thank you for that. Any other question or anything to be added? Any assistance that any of us requires or needs? Okay, anybody who's not been able to join the group, because that is the only sure way for you to get material and any other further communication from us. Right, fine. I think we can call it a night. Helen, you have anything to add or we close it? Yeah. I think we're good. All right, fine. I think that's fine. Thank you guys for being part of the training. We will have another session, I think week after next week. So we'll be able to share more with you guys through our channels and through email for those who have subscribed to our email communication. You'll get whatever details that you require from us through our official emails. Otherwise, thank you very much. Enjoy your evening.